In this training module, we'll explore features and operation of the FD322 tuning software that's supplied with the product. This module will be presented in two segments. First will be a brief overview of the software's operating modes. Following that will be a narrated video demonstration showing the software in use. Let's start the overview by listing the program's operating modes. They include the terminal mode, real-time mode, parameter editor, spectral history mode, and replay mode. Each of these functions is important in providing the user with the tools he needs to set up, monitor, and maintain the APU. Before discussing and demonstrating the modes individually, however, we must first connect the APU to your PC. A serial port and standard RS-232 cable are required to connect the APU to the tuning software. The port can either be a dedicated RS-232 port or a USB to serial converter, as shown here. Either way, the port setup is as follows: 9600 baud, 8 data bits, 1 stop bit, no parity, and set the flow control to none. The most basic tool is the terminal mode. It provides a low-level interface that enables the user to perform most setup and some monitoring operations. Although the tuning software provides the most convenient way of accessing the terminal mode, any terminal emulator program such as HyperTerminal can be used to gain access. The terminal mode provides a basic command line interface wherein a command is typed in by keyboard and a text response from the APU is shown immediately on the screen. The functions shown on the left of this example terminal screen can be performed in the terminal mode. The status command permits monitoring of current APU operating conditions, including laser current, most recent loss value, and a simple event and alarm display. The setup function provides access to menu-driven parameter query and editing. The calibration function performs loss measurement, APU signal calibration, and time and date setting. Entering the history mode allows access to the time and date of the 128 most recent alarms recorded by each APU channel. The version command gives APU information including model and serial numbers, firmware version, manufacturing date, and days in operation. The admin mode allows the user to control several system functions such as enabling or disabling the tamper input, adjusting the alarm relay time, and making the TCP/IP related settings. Finally, entering CHA or CHB allows the user to change the APU sensing channel being displayed. The graph shown here illustrates the tuning software's real-time mode. It shows a frequency domain representation of APU signal activity as it occurs, including event and alarm indications. The graph's horizontal axis shows frequencies between 10 and 600 Hz from left to right, while the vertical axis shows the relative amplitude of the signal at those frequencies. The real-time mode also allows for setup and recording of spectral data files to the host PC's hard disk, with recording either manually triggered or automatically triggered by events and/or alarms. The parameter editor provides a graphic view of current APU information and settings and allows current parameters to be reviewed, edited, and sent to the APU. There is a special feature that allows factory default parameters to be created for the purposes of resetting the APU. Parameter sets can be named and saved to the host PC's hard disk, and they can also be recalled from disk for review, sharing, and/or sending to the APU. Finally, the editor allows printing of displayed APU parameter settings. The spectral history mode allows retrieval of spectral data files internally stored on the APU. The processor is able to store the most recent 24 alarms per channel in its internal memory. To recall them for the purposes of analysis, they must first be downloaded from the APU, then selectively saved to the host PC's hard disk using the spectral history mode. The replay mode allows retrieval of spectral data files from the PC's hard disk and displays both frequency and time domain representations of a data file simultaneously. The recalled time domain data is displayed in a 10-second window at the bottom of the screen, showing the trigger event plus 5 seconds before and 5 seconds after. Color-coded symbols representing alarms and events from the cut and climb processors are displayed on the time domain waveform at the times of their occurrence. Cursors on the time display allow close examination of specific portions of the waveform for the purposes of fine-tuning the APU parameters. As the cursors are moved, the frequency domain display at the top of the screen changes to represent the frequency content of only the time window between the cursors in the time domain display. Using information gleaned from the replay mode, it's possible to more effectively use the tuning parameters to optimize the APU's performance. Now that we've introduced the tuning software, let's follow that with a demonstration showing the software in use. We've already connected the APU to the PC, so let's run the program. The first thing that needs to be done once the software is running is to select a COM port to provide a connection between the APU and computer. So we'll access the serial port flyout menu, and a list of available COM ports will appear. Select the port to which you've connected your APU, and then click on the Connect to COM port button. In a few seconds, the active COM port window will show that the selected port has become active, so we're done connecting to the APU. Click on the Close button to exit the serial port menu. The next thing we need to do is select an operating mode, so we'll click on the Modes button to bring up the menu. The flyout shows all of the possible operating modes, including Replay, Terminal, Real-Time, Parameter Editor, and Spectral History. We're going to start out in the terminal mode, so let's click on the Terminal button. The first thing you see in the upper left-hand corner of the screen is an indicator showing what APU channel we're working with. The software defaults to Channel A. To change to Channel B, type CHB and enter, and that channel becomes active. Let's return to Channel A and continue. Immediately to the right of the channel indicator is a message that says, CHA locked, enter password. Well, there really isn't a password. The software is simply asking you to enter a command. We're going to start out with the status command, so type status and enter, and you'll see some information appearing in the upper left-hand portion of the screen. Once again, the first item is the APU channel indicator, showing that we're still connected to Channel A. Now, let's analyze the rest of the status information bit by bit. The first measurement that we see shows the optical input power in microwatts that's being received by the detector. There's a better way to measure optical performance, however, and we'll discuss that in terms of a loss measurement in a few minutes. The next measurement shown is the laser current in milliamps. The laser sweet spot is in a range of 30 to 40 milliamps, and if it's ever outside that range by an appreciable amount, you may have a problem in your APU that needs attention. Now let's go down to the next line where the first thing that's shown is a loss measurement in dB. This is a measurement of the loss in your sensing element, showing the optical power loss between the laser output and the detector input. This isn't a live measurement of loss, rather it shows the most recent measurement and the time and date on which that measurement was made. We'll show you how to update that measurement in just a few minutes so that you can gauge the current performance of your system. The next measurement shown is the DC voltage at the power supply input terminals. In the third line of the display, you see 4 sets of brackets that are currently empty. Now I'm going to start wiggling the sensing fiber, and you'll see some indicators appearing in those brackets. These include Event 1, Event 2, and Alarm. The first set of brackets, then, indicates the occurrence of events from Processor 1, the climb processor. The second set shows events as they occur from Processor 2, the cut processor, and the third set shows when alarms occur from either processor. Now, we haven't seen anything in the fourth set of brackets yet, so what I'll do here is disconnect the optical sensing cable from the Channel A laser output. What appears in the brackets is a fault indicator. So this set of brackets indicates that there's some sort of optical fault in the sensing channel, primarily cuts or kinks in the sensing element that causes a large loss of optical power. A fault condition is accompanied by a continuous alarm, as shown in the third set of brackets. These indications will remain until the fault is cleared, so I'm going to plug the optical connector back into the laser output, and you see the fault and alarm indications go away, indicating that the fault has been cleared. As you can see, the status command gives you a lot of valuable information regarding the current health of your APU. You'll be using this command quite often during setup and maintenance of your sensors. The next terminal mode function we'll describe is the setup command, which provides access to a simple keyboard-driven APU parameter query and editing process. So let's type in setup to start our demonstration. Once again, the APU channel indicator appears in the upper left-hand portion of the terminal screen. Next, the currently accessible parameter and its present value are displayed. On the line below that is shown the permissible range for the parameter, as well as its typical or default value. The first parameter to be displayed is climb sensitivity. To change the value, type in the new setting and hit the Enter key. The new value is immediately and simultaneously displayed on the screen and sent to the APU. The sensitivity parameter has two parts, a numeric value and an enable/disable function. Only one of these can be modified at a time, so if it's necessary to change both, they must be done individually. For example, the current setting is now 30E, meaning that the climb processor is enabled and that the sensitivity is set to 30. To disable, type D and enter. Now, if we want to enable and change the value to 25, we must first type E and enter, then type 25 and enter. Once you're done with a particular parameter, each time you hit the Enter key, the next parameter in the list appears, and you can either edit its value or hit the Enter key to advance to the next one, like I'm doing here. When you've gone through all 7 parameters in the list, the setup mode is exited, and you return to the main terminal mode screen where you're prompted to enter a command. The next terminal mode feature is the calibrate function, which performs loss measurement, APU signal calibration, and time and date setting. A brief video segment that's shown in the calibration and tuning section of this training program will serve to illustrate the use of these essential operating procedures. Here, I'll just describe the calibrate function and how to access its various features. To access these functions, type CALIB and enter to bring up the calibrate menu. There are 2 choices, time and date setting and loss measurement. To view the current time and date, type D and enter. This will display the current time setting. Hitting enter again will display the current date setting. To change the settings, display the one you want to change, type in the new data, and hit enter to make the change. Note that the APU contains a battery-operated clock that maintains time and date even when the unit is not powered. It does not keep track of time zones or seasonal time changes, so you'll need to take care of that yourself. Time and date settings are important since they're used to stamp alarm and event occurrences. To measure the loss or calibrate the unit, access the Calibrate menu and type ML and enter. If you respond with Y when asked, "Are you sure?" the display shows the last measured loss value, and at that point you can perform the measurement and calibration processes. Again, this procedure is explained in a video segment that is shown in the calibration and tuning section of this training program. Entering the history mode allows access to the time and date of the 128 most recent alarms recorded by each APU channel. This data can be accessed by typing HIST and enter. The display will show how many alarms have been recorded. They can be reviewed by hitting the enter key. Alarms are listed in descending order starting with the most recent. With each enter, The next alarm in the list is displayed until the entire list has been shown. You can exit the list by typing Q and enter at any time. Each alarm entry will show the alarm number, the processor, cut or climb, that generated the alarm, and the time and date of the alarm's occurrence. If more than 128 alarms have occurred, the oldest alarms on the list were dropped as the newest ones were added. Note that cycling the APU's power off, then back on, will erase the alarm history. Don't forget this important fact. Use it to your advantage to reset the history when needed, but never forget it before turning off the APU's power. Now let's type version to access important APU information. This will display the APU model and serial numbers, firmware version, manufacturing date, and days in operation. This important information is always required when calling Fiber Sensys for technical support and when returning an APU to us for service. The admin mode allows setting of several important system parameters. After typing in admin and enter, the first parameter displayed allows control of the tamper input function. It can be enabled or disabled here. Next, the alarm relay time, which determines how long the relays remain in the alarm state after an intrusion has been detected, can be set. The range is from 1 to 10 seconds, depending upon the requirements of your alarm monitoring system. Next, the device name can be set. This allows the APU to be given a name that will appear in all XML reports from this APU when it's used in a TCP/IP network system. Next, APU channel A can be named, also for use in a TCP/IP network system. Then, APU channel B can be named for the same purpose. Finally, the APU's XML report interval sets the time period between messages sent over the TCP/IP network to let the system controller know that the APU is alive and well. That's it for the terminal mode. It's a very useful tool for working with the APU, and several important functions such as calibration, status, history display, and certain parameters can be accessed only from the terminal mode. Also remember that any terminal emulator program such as HyperTerminal can be used to access the terminal mode if the tuning software is not available. Now let's demonstrate the parameter editor. This useful function provides a graphic view of current APU information and settings and allows current parameters to be reviewed, edited, saved, and sent to the APU. Once again, we need to open up the Mode menu, and this time we'll click on Parameter Editor. When the parameter table first comes up, a progress bar indicates that the APU properties are being read. When loaded, the table provides a graphic view of current APU information and settings, starting with basic APU info at the top of the table, followed by the climb processor settings, cut processor settings, win settings, and miscellaneous settings. The values in the white column represent current settings, while the values in the pink column represent factory default settings. To change a particular parameter value, click on its current setting in the white column, and the value to be changed turns blue. For example, let's disable the climb processor. Click on the current value, yes in this case. For a yes/no parameter, a down arrow appears in the cell, so click on it to reveal a drop-down list with the available choices. Click on no to disable the climb processor, and note that the parameters below it turn pink to indicate that they are no longer applicable since the processor has been disabled. Now let's change a numeric parameter, such as cut sensitivity, for example. Click on the setting and use your keyboard to enter a new value. Note that to the right of each parameter name, a set of parentheses shows the permissible range of values. If you attempt to enter an out-of-range value, an error message will appear to inform you of your mistake. Changing the parameters in the table doesn't send the new values to the APU. The controls in the process window on the right side of the screen allow parameters to be moved. To move parameters to or from the APU, click on Send or Receive in the APU section of the process window. Let's send our edited parameters to the APU. The progress box indicates the status of the operation as it's being performed. Parameter sets can be named and saved to the host PC's hard disk, and they can also be recalled from disk for review, sharing, and/or sending to the APU. The Open and Save buttons in the File section of the process window can be used to perform these operations. When either is executed, a browser opens to locate the source or destination of the parameter file. There's a special feature that allows factory default parameters to be created for the purposes of resetting the APU. Review the changes we've made to our parameter table here. To revert to factory defaults, click on the Create Selected Parameters button and note that all of our changes have been reverted to defaults. Don't forget to send the defaults to the APU to reset it, though. As in the real-time mode, the APU info window displays the type of APU and channel to which you are currently connected. You can change the currently viewed channel by clicking on the Switch Channel button. Finally, the editor allows printing of displayed APU parameter settings. Just click on the Print button and a graphic view of the parameters shown will be printed on your default printer. Now let's demonstrate the real-time mode. Once again, we need to open up the Mode menu and we'll click on Real Time. When the screen first comes up, a progress bar indicates that the APU properties are being read. When this is finished, the dark blue line at the bottom of the screen will turn light blue and the signal is now live. The real-time screen shows a frequency domain representation of APU signal activity as it occurs. The graph's horizontal axis shows frequencies between 10 and 600 Hz, while the vertical axis shows the relative amplitude of the signal at those frequencies. Notice that as I shake the sensing cable, the signal appears. Every once in a while, the screen will turn yellow to indicate that an event has occurred, and when it turns red, that signals the occurrence of an alarm. The real-time mode also allows for recording of spectral data files to the host PC's hard disk, and the controls for doing so are located on the right side of the screen. At the top in the Trigger section, recording can be set to automatically trigger on events and/or alarms. The first step is to choose what the trigger will be. So let's set up to record on all alarms by checking the Alarm 1 and Alarm 2 boxes for climbs and cuts, respectively. The next step is to enter a 5-character file name prefix in the File Data box. The current sequence number box will start with 0, indicating that there are currently no files saved with the chosen prefix. As files are recorded and saved, the sequence number will be appended to the prefix to form the spectral data file name. Let's use demo as our prefix. The final step is to click on the Enable Recording box to put a check mark in it. Automatic recording is now enabled. So let's create some recordings. First, note the black line below the real-time screen. This indicates that the program is not currently recording. I'll wiggle the cable a bit until the screen turns red to signal an alarm. Notice that the black line at the bottom has also turned red to indicate that a recording is in progress. When it turns black again, the sequence number is incremented to show what the next file name sequence number will be. Let's create another alarm. After being saved to disk, the sequence number increments to 2. You can leave the setup running, and when you return to review the progress, the sequence number will always show you how many files have been recorded. Manual recording can be triggered at any time, even while in the automatic recording mode. Just click on the Manual button to make the next recording in the current sequence. Note that the replay mode will be used to recall stored spectral data files for review. We'll discuss those functions later in this training program. The final function in the real-time mode is the Switch Channel button in the APU info panel. This portion of the screen will always tell you what type of APU and which channel you're connected to. To change channels, just click on the Switch Channel button. Note that the word fault appears at the top of the signal display in this case. That's because there's no optical cable connected to channel B on this APU. So remember that if there's a fault condition, it will be indicated on the screen as shown here. That's it for the real-time mode. This function will be used quite a bit when tuning your APU and when you need to capture recordings of intrusion and nuisance events. The spectral data files are small, about 10 kilobytes in size, and can easily be attached to emails. Our tech support team can therefore easily help you analyze your fence signals so that your APU is properly tuned for detection of intrusions and rejection of nuisances. Now let's check out the spectral history mode. Once again, we need to open up the mode menu, and this time we'll click on spectral history. When the history table first comes up, a progress bar indicates that the APU properties are being read. Once this is complete, it's possible to retrieve the spectral data files internally stored on the APU. The processor is able to store data from the most recent 24 alarms per channel in its internal memory. To retrieve them, click on the Load History button in the Functions window on the right side of the screen. In a few seconds, a time and date stamped list of the stored alarms appears in gray in the middle of the screen. The alarms are numbered, with the oldest on the bottom of the list. At this point, the data is still in the APU and can be loaded all at once or selectively loaded. Before starting the load process, enter a 5-character file name prefix the same as we did when recording files in the real-time mode. The same prefix /sequence number file naming convention will be used here also. To selectively retrieve the data, click on your choices in the list. Selected records will turn yellow. Then click on the Save Selected History button to retrieve and save the files to your PC. A few seconds later, a prompt will appear to let you know that the data transfer has occurred. Click on OK and you're done. You can now load and examine the spectral files in the replay mode. Had we wanted to retrieve all of the history data, we would have clicked on the Save All History button. Finally, there's an APU info screen that displays APU type and channel information, and you can change the channel from which to recall data by clicking the Switch Channel button. The final function to demonstrate is the replay mode, which allows retrieval and display of spectral data files from the PC's hard disk. Both frequency and time domain representations of the data are displayed simultaneously. To retrieve a file, click on the Load File button in the File Name section on the right side of the screen. This will bring up a browser so you can choose the file to recall. Note that the software has a default storage location for saving spectral data and APU parameter files. This location is a folder named Data, and it's located in the folder in which the FD322 tuning software has been installed. So let's load one of the demo files that we've created during the course of this training session. Clicking on the Load File button brings up the browser. Now we'll navigate to the FD322 software's installation folder and open the Data folder. We'll click on the desired file name and then Open to load the file into the replay screen. The APU info box presents some data regarding the recalled file, including APU type and channel and a time and date stamp for the recording. If there are a number of files that have been stored in the same sequence, the Next and Previous buttons can be used to navigate through the files. Now let's examine the file that we've recalled. The time domain data is displayed in a 10-second window at the bottom of the screen, showing the trigger event in the middle, plus 5 seconds before, and 5 seconds after. Color-coded symbols defined in the status legend box in the upper right corner represent alarms and events from the cut and climb processors. These symbols are displayed on the time domain waveform at the times of their occurrence. Cursors on the time display allow close examination of specific portions of the waveform. As the cursors are moved, the frequency domain display at the top of the screen changes to represent the frequency content of only the time window between the cursors. Let's move the cursors to surround the trigger alarm event at time 0.0. The frequency display, which is equivalent to the one in the real-time mode, changes to reflect only those frequencies present in the time window between the cursors we've placed in the time window. And if you hold down the right mouse button, both cursors will move simultaneously. Using information gleaned from the replay mode, it's possible to more effectively use the tuning parameters, such as low frequency cutoff, to optimize the APU's performance.